The project begins when Andy drops a marble with a ton of gravitational potential energy through a funnel and down a tube as it loses gravitational potential energy in a linear motion. It then goes out of the tube and hits the Newton's cradle. The Newton's cradle works in a circular motion due to the wires holding it up. The ball at the end moves due to Newton's third law. For every force acting on an object, there is an equal and opposite force reacting. The marble hits the first Newton's cradle ball and sends the force to the second ball this way until the final ball is kicked out, hitting the dominoes. Then the dominoes move in a linear motion. The Newton's cradle ball knocks over the first one, causing gravity to pull the tilted top down upon the next domino. Then it repeats. The last domino hits a slightly larger domino, an Uno deck, sending it off the edge. The Uno pack is a linear motion caused by gravity pulling it down and accelerating it. It falls into a plastic tub. The tub is on a balance that works like this. Since it is all part of one system, the Uno deck causes the balance to flip in a circular motion by creating a torque. The Uno deck side hits the ground, while the other side flies up. The other side of the balance is attached to a string which is attached to an alcohol burner. In a linear motion, the string moves upward and right. The string moving causes the momentum of the alcohol burner to change from 0 to a higher number since it is in motion. While the applied force from the string is at an angle, the alcohol burner moves directly right because of its weight, until the flame is under the rope. Now the string burns, which isn't really a motion but counts anyway because of the linear motion of the rope pulling up after it has been broken. Heat energy from the flame was hot enough to singe the fibers of the rope until they all broke, separating the rope into two. The weight falls in a linear motion because the force of the rope is no longer countering the force of gravity. It falls and accelerates as it does, but not much since it's such a short fall. The platforms then move in circular motions. The weight applies a torque, pressing down on the left of the first one. Since it is a unit, the right side of the first platform applies an upward force in a circular motion on the left bottom side of the second platform. Since that too is a unit, the right side tips down in a circular path. The Mentos placed on the right side of the second platform now dump off into the funnel and into the Coke bottle in a linear motion due to gravity, losing gravitational potential energy the whole fall down, which it turned into kinetic energy. The Mentos also have chemical potential energy, which is expressed when the soda reacts. The soda also has chemical potential energy, and when the two combine, they create a chemical reaction that causes the Coke to foam, expand, and move in a linear motion out the top of the can and into the holding tub below. The Coke continues to fall through the two holes in the bottom of the tub, which is tipped so gravity will make the Coke go down to the two holes. The Coke falls through the holes and onto the paper in two streams. Behind the paper are 3 plastic boards duct taped to it. Between the 3 boards are 2 spaces where it is just paper. This is where the Coke should fall. On the middle board is a weight pulling the top of the paper down by gravity in a linear motion, but the dry paper is too strong to tear. When the paper gets wet from the Coke, the bonds holding it together weaken and the weight is strong enough to pull the middle section down and away from the other 2 pieces, cutting the paper into 3 pieces. This is another linear motion caused by gravity. Overall, our chain reaction was a success. Though we had to interfere once to put the alcohol burner in the correct place, we still cut the paper into 3 pieces. Our Rube Goldberg used 14 unique steps, though many of them used the same type of motion. Each step worked individually to transfer energy to the final cause of tearing a sheet of paper. Our weaknesses lie in the first half, where the setup was not based on precise measurements, but instead on a guess-and-check method of setup. For this reason, the dominoes didn't fall on our first trial, and the alcohol burner did not move to the correct place on our final trial. If we were to change something, it would be to make this part more precise. We were strong in the second half, where the setup was more precise, and most of it was already taped together from when we got it to work in my garage. The weight fell onto the platform smoothly, the Mentos always dropped into the Coke, and the Coke streams were always in the correct place. It was kind of scary at the end because the weight took a while to work to tear the paper, but the paper ripped into 3 pieces in the end anyway.